All right, example 1, the line and the parabola graph in the figure divide the coordinate system into 4 distinct regions which have been labeled A, B, C, and D. Which region contains the coordinates of the points that satisfy the given system of inequalities? So what we have here is a linear inequality and we have a quadratic inequality. So the linear making the line, the quadratic making the parabola. And it says 4 distinct regions. Notice C is 2 of those. All right, so it's actually, looks like 5 regions. But think of things either inside or outside the parabola, above or below the line. So if we look at region A, that's above the line, it's outside the parabola. Region B is above the line, inside the parabola. Region C is below the line, outside the parabola. Region D is under the line and inside the parabola. So if you think inside, outside for the curvy thing, above and below for the line, then that gives you those distinct regions. So if C is the right answer, we would be shading here and here. D is the right answer, we just shade in this region, B here, and A over there. All right. You do not have to draw the graph. All you need to tell me is the correct region is shade. All right. This technique will work for 2 lines also. If you, just doing what we've been doing already, if here's line 1 and there's line 2, if you want to call them region A, B, C, and D, you're welcome to do that. The technique I'm going to show you today will work for what we've been doing. I just don't show it that way usually. I just kind of draw arrows. But if that makes it more sensible, if what I'm showing you today is more sensible than what we've done before, by all means, feel free to put A, B, C, and D when you get 2 lines intersecting, and you can do it the way we're going to do it today. Okay, all we need is a test point. Oops, going the wrong way here. All we need is a test point. It doesn't matter what the test point is as long as it does not lie on either graph. I could pick the test point. I'm going to pick this one over here just to be different today. I just feel like being different. There's my test point. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So my test point is x equals 5, y equals 5. So on every one of these problems that you get of this variety, that's one thing I'm going to expect to see on your paper, the words test point. You can abbreviate TP if you want, test P, whatever. I don't care what you write. But identify the x and y coordinates of that test point. And then what we're testing are the 2 graphs. So this is my first test. You know, I just made a decision. I'm going to make my test point 6, 5.
Oh, yeah, because I've been missing.
And that's the nice thing about test points is if you don't like it when you start off, you can always change your mind. All right. The reason I want 6, 5 is because I'm doing half of x, right? Half of 6 is 3, half of 5 is 5 halves. I can avoid fractions that way. All right. So my test point is 6, 5. It's over here. And it's not on either graph, right? So what I'm going to do is I'm going to replace in this circled inequality, I'm going to replace y with 5, x with 6, and simplify and see whether it's true or false. So if I put y equals 5, don't worry about the equals to, just worry about the greater than or less than. It's not going to be equal to because it's not sitting on the line. All right? So y 5 is greater than half of x, half of 6 is 3 minus 4. That's 5 is greater than -1. True or false?
True.
True. All right. Now, it is up to you to know which equation's which. All right. Y and x, both the first power is linear. That's the line. So what we're focusing on here is the line, which is right here. All right. Now, what I want to look at here is the test point is up here, right? Above the line. What else is above the line? Which regions? B and A are both above the line. So the fact that this is a true statement tells me both A and B are correct for the line. So if I was just graphing the line, nothing else, and I was doing linear inequality based on this line, I would do this line here and I would shade everything above it. That's what the graph of the line would be. All right. Then I want to test, same test point. It don't have to be the same test point. I could pick something over here if I wanted to for the other test point. I tend to use the same one every time though. I think it's easier. All right. I'm replacing y with 5. Again, I'm only worried about the greater than, not the equals to. Because again, I'm not picking it on the graph itself. It's not going to be equal. So just worry about the greater than or less than part. And I got to do 6 squared, make it negative. 4 times 6 is 24, minus 1, that's 5 is greater than -13. That's also true, right?
Yep.
All right. So the test point is over here. In relation to the parabola, it's outside the parabola, right? So the truth is outside the parabola. What else is outside the parabola is A and C, right? So for the blue line, A and B are correct regions. For the red parabola, A and C are the correct regions. The region we care about is the one that's in both of them. So the correct answer to this problem is region A. And that's how you write your answer on your homework. You do not have to graph these, just tell me which region you need to graph. The graph will be drawn for you just like this. The regions will be marked A, B, C, D. And that's how you do it.